Hey, good morning, Math 1. Today we are doing the notes for Chapter 3, Section 3. We're going to talk about parallel and perpendicular lines and a little bit about rotations. The thing we want to do here is we want to be able to understand the relationship. There it is.
At the class change, if Benjamin Lloyd could please stop by the remote office.
The relationship between parallel lines and perpendicular lines, and maybe more importantly, be able to write equations for lines that are parallel or perpendicular to a given line. I'll get through all of that relatively quickly here. So on the coordinate plane at the right, it wants us to graph this line. This should be an easy skill from Chapter 2, right? It's got a y-intercept of -4. I'm going to slide up a little bit here. It's got a slope of 3/5, and of course 3/5 means to go up 3 and right 5. So 1, 2, 3, 1, 2, 3, 4, 5. Boom, I have drawn the line. Now, it wants me to translate the line up 5 units. A translation, remember, is just sliding it. To translate it, pick any 2 points on the line, like maybe these two, right? And translate them using the given translation, which for us, the given translation is up 5. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to connect them to draw the translated line. Bam! What is the equation of the resulting line? Well, the resulting line has a y-intercept of 1, right? And it's got a slope. If I draw a slope triangle, it's got a slope of 1, 2, 3, 1, 2, 3, 4, 5. It's got a slope of 3/5. So b equals 1, slope equals 3/5. And the equation for this line would be y equals 3/5 x plus 1. All right, this is the main thing we want to talk about right here. What is the relationship between the original line and its image, right? What is this relationship between these two lines? Well, I'm sure you probably know this. These two lines are parallel. I need to slide up a little bit more. They are parallel. We all know what parallel lines are. They're two lines in a plane that do not intersect. They basically go in the same direction, right? That's what it means to be parallel. But the thing we want to look at today is, how do their slopes compare to each other? What is the slope of these two lines? Well, the red line has a slope of 3/5. The blue line also has a slope of 3/5, so their slopes are equal. And that is the main thing we want to point out here. When two lines are parallel, their slopes are the same. So, in geometry, two lines are parallel if they are in the same plane and do not intersect. But we're looking at algebraically. What do we know about parallel lines algebraically? They are algebraically, two lines are parallel if they have the same slope. That is how you can tell that two lines will be parallel to each other, because their slopes are the same. And so now, if I gave you an equation for two lines, without even graphing them, you could tell me if they're parallel or not, because their slopes would either, if they're parallel, their slopes would be the same. All right, that's the easier of the two. Now we need a couple things on background information. Our first background information is rotations. It occurred to me that I'm not sure how good we are at rotations, so I wanted to review them from Math 8 here briefly. Do we know how to rotate a point or a figure around the origin. So this is how I taught my Math 8 class to do it. I say just turn your paper, right? The amount of the rotation. So we're going to do this with this point P over here. We are going to rotate point P 90 degrees clockwise. Do we know that CW stands for clockwise? All right, so I'm going to rotate point P 90 degrees clockwise. Let's do this. So here's how you do it. You start by just turning your paper 90 degrees clockwise. Let me do that. Oops, let me get rid of that. Oh my goodness. Boom. Okay, let me rotate my paper 90 degrees clockwise. So you could actually turn your paper like this. Clockwise would be in this direction, right? The way a clock goes. I turn my paper 90 degrees clockwise, and I have now rotated point P 90 degrees clockwise. So now I'm going to do this. I'm going to observe the coordinates of where it ended up. This is where the image would be if it rotated 90 degrees clockwise. Well, point P is now at the ordered pair 2, -3. Right? This is like my x-axis now, even though it was the y-axis. This is now the y-axis, even though it was the x-axis. And point P is at -2 or +2, -3. So now that I know where it's going to end up, I can turn my paper back. Let's go ahead and turn our paper back to its original position. I am stuck. I'm not sure why. Oh my goodness. Oh, the board is frozen. Unbelievable. Well, this is not good. I sadly am going to have to do this. Maybe. And do this. Sorry about this. Cost us a minute. And let's go back here. And so, hopefully this is going to work. And I believe that we just found out when we turned our paper, oh my goodness. When we turned our paper, we found out that the point was at the point 2, -3.
Mr. Flynn, you have a call parked on 1. Mr. Flynn, call parked on 1. Thank you.
So now that I've turned my paper back, let's graph that where it ended up. That was right here. That's where it ended up when I turned my paper. So that is where P prime would be. I graphed the image at the coordinates that I observed, right? These were the coordinates I was at when I turned my paper. That is how you can rotate a point, right? And point P could rotate all the way around the origin, right? Point P, if I rotated it, would end up somewhere on this circle, depending on how many degrees I decided to rotate it. I did a 90-degree example. All right, hopefully you got that. We also need to know what the word perpendicular means. Perpendicular, what does it mean? Well, it means, let's see, 2 lines are perpendicular if they intersect at a 90-degree angle. And you guys probably know that a 90-degree angle is a right angle. When 2 lines intersect, if they make a right angle, if they make a 90-degree angle, then they are perpendicular to each other. And I want you to see this. You show that 2 lines or segments are perpendicular by using a little square symbol. So if I have two lines and they are perpendicular to each other, right, there's a little square you put in there that shows, hey, those two lines make a 90-degree angle. Also, the symbol for perpendicular is an upside down T. Sometimes that's easier to use than the word perpendicular. All right, so now we're ready to do this. On the coordinate plane at the right, we want to graph this line. Now, I've already done it for you. It had a y-intercept at -1, so I put a dot at -1. The slope was up 3, right 2, and I graphed the line. So I want to rotate this line 90 degrees clockwise so that we can study what it means for a line to be perpendicular. So to rotate this line, I'm going to pick any 2 points, and I've already picked my 2 points. Here they are, right? And I'm going to rotate each of them 90 degrees, and I did say clockwise about the origin. So to do this, of course, I'm going to turn my paper, boom. I didn't get far enough up there, that's a little sad. There we go. I'm going to turn my paper 90 degrees clockwise, boom. And I'm going to see where those points ended up. So those 2 points ended up right here and right here. So they ended up at -1, 0 and 2, -2. All right, that's where my 2 are. There's -1, 0 right there and 2, -2 right there. So I'm going to turn my paper back and graph those. So let me go ahead and do this. Let me turn my paper back. And now I'm going to graph where those ended up. And that would be at -1, 0 and at 2, -2. And this would be my line rotated 90 degrees about the origin. All right, this is the pre-image, and this is the image. Right? The pre-image is the original line. The image is the line after I rotate it 90 degrees. Can we get the equation of the resulting line, the image? Start working on a different color. All right, so the equation for this new line would be, I can't quite tell what the y-intercept is, but I do know the slope. The slope is down 2, right 3. So it's -2/3 x, and it's going to be minus something. How can I get the y-intercept? Well, one thing I could do is I could use the slope and a point. I could say, let's take this point and go y minus 0 equals -2/3 times x plus 1. And I put it in point slope form. And wow, now if I just solve for y, it looks like the y-intercept was also -2/3, which looks about right, doesn't it? Isn't that point slope form handy? I think it is. All right, so here's the deal. What is the relationship between the original line and its image? Well, because I rotated it 90 degrees, we know that these lines form a 90-degree angle, and therefore they are perpendicular to each other. And look at how their slopes compare to each other. The slope of the new line is -2/3. The slope of the original line was 3/2. So how do their slopes compare? Look at those numbers. They are opposite reciprocals. They are flipped over and they are the opposite sign. Perpendicular lines. So here's our summary. Algebraically, two lines are perpendicular, which means they form a 90-degree angle, if their slopes are opposite reciprocals of each other. Examples of perpendicular slopes would be like 1/2 and -2/1, or just -2. Or how about -3/4 and +4/3? All right, I don't think we need another one. All I'm doing is taking the slope and flipping it over and changing the sign to get the opposite reciprocal. What about a slope of 0? What would be perpendicular to that? Well, that's a weird one, but it's undefined. You know, like 0/3 and 3/0. 0/3 is 0, and -3/0 would be undefined. All right, so now we're ready to do an example. We have learned how to write the equation for a line if we know the slope and we know a point on the line. Right? We did that last chapter. You could use the slope and the point to solve for the y-intercept, or you could use the slope and the point and use point-slope form. So the only thing new we're adding here is we are now telling you that your line is parallel or perpendicular to some other line. And that is just I like to say this, that is just a fancy way of letting you know the slope of your line. Let me do an example. That's a little confusing probably for you. So given that we have a line, y equals 3x minus 11, we want to write an equation in slope-intercept form of the line that is parallel to it. All right, so part A, the fact that my line is parallel to this line simply means that it has the same slope. All right, so since the slope of that line is 3, the slope of my line is 3. See how telling you that my line was parallel to that line is just a tricky way of helping me figure out the slope of my line. Oh, my line's got the same slope. It must be 3. And now I know a slope and a point, so I can write the equation. I like to use point-slope form. Y minus 19 equals 3 times x plus 7. That would be the equation in point-slope form, right? And then if I wanted to, or I was asked to, I could change it into slope-intercept form. I could distribute the slope, and I could add 19 to both sides. And I would get y equals 3x plus 40. So that's how you write the equation for a line that's parallel to a given line. What about perpendicular? All right. Perpendicular, okay, so I want to be perpendicular to this line now and go through this point. Well, again, telling you that your line is perpendicular to this line just means that you know the slope. If the slope of this line, the original line, is 3, then your line would be -1/3, right? It'd be the opposite reciprocal. And so now we actually know the slope of our new line. It's the opposite reciprocal of that line. And now I can use my point and my slope to write an equation. Be y plus 17 equals -1/3 times x minus 15. And if I wanted to, I could put it in slope-intercept form by distributing and then subtracting 17 from both sides, right? I think that's good. I think you can use those examples to help you on your homework. Good luck.